Hey everyone, ready for another deep dive?
Always.
Awesome. Today we're going to be looking at Defocus.
Wow.
It's this really cool AI that's making waves in the world of VR.
Right.
You know how sometimes VR can feel like a little off?
Yeah.
Well, we're going to explore how Defocus is trying to fix that.
Cool.
And the way it does it is seriously mind-blowing. It's like something straight out of a sci-fi movie.
Oh, wow.
Our main source for this deep dive is a research paper from Facebook Reality Labs.
Okay.
Those are the folks who are basically building the future of VR.
I see.
Get ready for some aha moments as we discover how AI could make VR so real you won't believe your eyes.
Sounds good. What's so cool about Defocus is that it tackles this problem that's been plaguing VR forever.
Oh.
It's called vergence accommodation conflict.
Okay, vergence accommodation conflict, what is that?
It's a bit of a mouthful,
Yeah,
but it's the main reason why people get eye strain or headaches in VR.
interesting.
You see, when you look at something close up in the real world, your eyes kind of angle inwards,
Yeah.
right? And at the same time, the lenses in your eyes adjust to keep things in focus.
Right.
Now, in VR, these two things get out of sync because current VR headsets, they have a fixed focus.
Okay.
So it doesn't matter where you're looking in the virtual world.
Right.
The image on the screen stays in focus in the same way,
I see.
but your eyes are still trying to do their natural thing, like in the real world.
So they're getting mixed signals.
Exactly. Your eyes are saying one thing, and the VR headset is saying something else.
So basically it's like our brains are getting a does not compute error.
Yeah, that's a good way to put it.
And that's why VR can feel uncomfortable sometimes.
Exactly. But that's where deep focus comes in to save the day.
Oh, how so?
Deep focus is a special kind of AI.
Hmm.
It's called a convolutional neural network.
Okay, I've heard of those.
Imagine you show a kid a bunch of pictures of, let's say, cats and dogs.
Right.
Eventually, they learn to tell the difference, right? Deep focus is similar.
Oh,
But instead of cats and dogs, it's analyzing tons of images and depth information.
wow.
It learns how things should look at different distances.
Uh-huh.
And then it uses that knowledge to create images for VR that have natural-looking blur.
So it's like Defocus is giving VR a new pair of glasses.
Yeah, like a really, really fancy pair of glasses.
That can adjust in real time.
Exactly. To make everything look super realistic.
That's amazing. And what's even cooler is that Defocus doesn't just work with one type of VR display.
Nope.
The paper highlights how it works with 3 different kinds.
There's so many new displays coming out.
Yeah, it's almost like a jungle out there.
Uh-huh.
Can you be my guide through the VR display jungle?
Sure. Let's start with varifocal displays.
Okay, what are those?
So picture this. A VR headset where the lenses can actually change their focal length.
Wait, like our eyes?
Exactly.
Do the lenses physically move?
Yes. Some varifocal displays use electronically tunable lenses.
Yeah.
Others have these tiny motors that move the lenses.
Crazy.
But even with this cool hardware, you still need software to create those images with the right blur.
I see.
And that's where deep focus comes in.
Ah.
It makes sure that everything looks sharp and clear as your eyes focus at different depths in the virtual world.
So Defocus takes the normal VR image, adds in the depth information, and then bam, it creates images specifically for our eyes focus.
Yeah.
It's like a virtual cinematographer who's adding those perfect focus effects to make the scene look more cinematic.
That's a great analogy.
What about multifocal displays?
Multifocal displays, well, think of them as having multiple tiny screens inside the headset,
Oh,
each one showing a slightly different version of the scene focused at a different distance.
so as our eyes move around and focus on different parts of the virtual world,
Yeah.
they're basically picking up the right image from the right mini screen.
Exactly. It's
Well-
pretty complex.
Yeah, it's making my brain do gymnastics.
But to make it work, you need to figure out how to split the original VR image and send it to those multiple focal planes. It's a lot of calculations, and deep focus helps with that.
Ah, so it streamlines the whole process.
Yeah, it's kind of like a multitasking master.
Gotcha. Okay, last but not least, what about light field displays?
Light field displays are the most complex. Imagine a headset with a ton of tiny projectors,
Whoa, wow.
each one pointing in a slightly different direction.
Okay.
As your eyes move and focus, they sample different parts of this light field, creating a naturally blurry image
Yeah.
based on what they're seeing.
So it's like having a mini 3D movie playing out in front of your eyes.
Yeah, sort of.
Yeah.
The challenge is creating all those different viewpoints.
I can imagine.
And that's where deep focus comes in again.
Oh, how so?
It takes a limited set of images and uses its AI magic to create all the other viewpoints needed for that complete light field.
So it's not just adding blur, it's actually creating new images.
Uh-huh. Based on the information it already has.
Okay, I'm starting to understand why we're calling it a hero. This is amazing.
It really is.
But we're not just talking about making VR games look better, right?
No, not at all. This has the potential to change everything from medical training to architecture.
Oh, wow.
Imagine a surgeon being able to practice a complex surgery in VR.
Like a flight simulator for surgery.
Yeah, exactly.
That's incredible.
It could make things so much safer.
And it could revolutionize medical education, too. Students could learn by interacting with virtual models of the human body.
Uh-huh. They could zoom in and see everything up close.
It'd be like a field trip inside the human body. What about architecture?
Architects could create virtual walkthroughs for their clients.
So instead of just looking at blueprints,
Right.
clients could actually experience the space in VR.
Exactly.
That's a game changer.
They could see what it would feel like to be in the building even before it's built.
And they could experiment with different materials and colors.
Yes, all in real time.
It would be like having a virtual interior designer. Wow.
The possibilities are pretty much endless. We're just scratching the surface here.
I'm getting really excited about the future of VR.
Me too.
It sounds like deep focus could have a huge impact on how we learn, work, and experience the world around us.
Absolutely. And we're just getting started.
This is really fascinating.
The research paper goes even deeper into some specific examples of deep focus in action.
Oh, really?
And some of the results are truly mind-blowing.
Okay. I'm all ears. What stood out to you?
Well, let's talk about this scene they tested with a lot of complex occlusions.
Occlusions, what does that mean?
It's when objects are blocking each other,
Oh,
like a
okay.
busy street with lots of people walking in front of each other.
Gotcha.
It can be hard for computers to figure out the exact depth of objects that are partially hidden.
Yeah, I can imagine.
Traditional methods tend to struggle with that, and it can make the blur look wrong.
I see.
It's like trying to take a clear picture through a messy window, but Deep Focus was able to cut through all the clutter and accurately estimate the depth, even in those tricky situations.
So it's like deep focus has X-ray vision for depth.
Haha, kind of.
That's amazing.
It's like Deep Focus just gets it, you know? It has this intuitive sense of how depth works in the real world.
That's really cool.
But, you know, it's not perfect.
Ooh.
The paper does mention some challenges they're still working on.
Ah, okay. Like what?
One thing that trips up Deep Focus is semi-transparent objects.
Oh, like glass.
Exactly.
Yeah, I can see how that would be tricky.
Light passes through glass and bends in all sorts of ways.
Right.
So there's not one single depth value for a glass object.
It's like a mirage.
Yeah, kind of. It's hard to pin down the depth information.
I see.
The AI is getting incomplete information,
Right.
so it can't always create a perfectly realistic blur.
So figuring out how to handle glass is still on the deep focus to-do list.
Yeah, they're working on it.
What about other things? Are there any other areas where deep focus might not be as good?
Well, another thing is scenes with extreme depth ranges. Deep Focus was trained on a certain range of depths,
Okay.
and it might struggle when things get really close or really far away.
Like if you're trying to simulate a tiny ant or a distant galaxy.
Exactly. It needs more experience with those kinds of extreme scenarios.
Right.
But, you know, even with these limitations,
Uh-huh.
what Deep Focus has achieved is really remarkable.
You're right. It's of a student who aced their exams but still has a few things to learn.
Exactly.
Speaking of learning, let's shift gears a bit and talk about the bigger picture.
Okay.
We've touched on the potential of deep focus beyond gaming,
Uh-huh.
but I'd love to dive deeper into that.
Sure.
What other fields could benefit from this technology?
Well, we talked about medical training. Imagine surgeons practicing complex procedures in VR,
Right.
feeling like they're in a real operating room.
It's like a flight simulator for surgery.
Exactly.
That's amazing.
It could be incredibly valuable for training and safety.
Yeah, I see that.
And think about medical education.
Uh-huh.
Students could use Deep Focus to explore virtual models of the human body.
Oh, wow.
They could zoom in and out, see everything in incredible detail.
You're like taking a field trip inside the human body.
Haha, exactly.
What about architecture?
Architecture is another exciting area.
Yeah.
Architects could create virtual walkthroughs that let clients experience a space before it's even built.
Right. So instead of just looking at blueprints,
Yeah.
clients could actually walk through the virtual building.
Exactly.
That would be amazing.
They could get a real sense of the layout, the design,
Uh-huh.
all in VR.
And they could experiment with different materials, colors, lighting.
Yes, all in real time.
It would be like having a virtual interior designer.
That's a great way to put it.
Wow.
The possibilities are really mind-boggling.
They really are. It's making me think about how deep focus could even change the way we connect with each other.
Oh, how so?
Imagine having virtual meetings or hangouts with friends and family that feel as real as being in the same room.
That would be incredible.
They're right there with you.
Yeah,
This is getting me really excited about the future.
me too.
It's like deep focus is opening a doorway to a whole new world of possibilities.
It really is.
Not just in VR, but in how we learn, work, play, and connect with each other.
And remember, this is just the beginning.
Right.
As deep focus continues to evolve and improve, who knows what other amazing applications we'll discover?
That's what I'm thinking.
It's an exciting time to be following these developments.
Absolutely. Okay, we've covered a lot of ground here.
We have.
From the technical details of how deep focus works to its mind-blowing potential applications.
Oh, yeah.
But before we wrap things up, I want to circle back to something you mentioned earlier
Sure.
about deep focus possibly helping us understand human vision better.
Oh, yes.
Can you elaborate on that?
Of course. It's a fascinating area that's worth exploring further.
Yeah.
We've now created this AI that can mimic how our eyes focus.
Right.
What if we could use deep focus to actually study how our brains process visual information?
So we could use it as a tool to unlock the secrets of our own visual system.
Exactly.
That's a really intriguing idea. What kind of insights could we gain?
Well, imagine we could create these virtual environments with deep focus that specifically test how we perceive things like depth, motion, and color. We could even use it to study visual impairments,
Oh, wow.
potentially leading to new treatments or assistive technologies.
So by studying how deep focus works, we could potentially unlock new therapies for people who have difficulty seeing.
Exactly.
That's incredible.
It's like we're using AI to enhance our vision, not just in the virtual world, but to improve our understanding of vision in the real world.
That's amazing.
You know, it highlights a really important point about scientific discovery. Often, when we set out to solve one problem, we end up opening up entirely new avenues of exploration, leading to breakthroughs we never expected.
This whole conversation has been full of aha moments for me. It's really made me think differently about AI and its potential.
That's great to hear.
It's amazing to think of deep focus not just as a cool piece of tech,
Yeah.
but as a key that could unlock a deeper understanding of ourselves and the world around us.
It's a powerful analogy.
It really is.
As we continue to delve deeper into the world of AI and virtual reality,
Oh.
who knows what other doors we might open.
This deep dive has been an incredible journey filled with insights, possibilities, and a healthy dose of wonder.
I agree. It's been a pleasure exploring this topic with you.
Likewise. The future of AI and virtual reality is brimming with potential. It's an exciting time to be witnessing these advancements.
Absolutely. And to our listeners, we hope you've enjoyed this deep dive as much as we have.
We encourage you to check out the research paper and keep exploring the ever-evolving world of technology.
Until next time, keep those minds curious.
And keep those imaginations sparked.
One example that really stood out to me in the paper was this scene with a bunch of complex occlusions.
Complex occlusions.
Yeah, it's basically when you have a lot of objects blocking each other.
Oh, okay.
Like, imagine a busy street scene
Right.
with people walking in front of each other.
Yeah.
In those situations, it's really hard for traditional methods to figure out the depth of each object,
I can see that.
especially the ones that are partially hidden, right?
Yeah.
So it leads to all these errors in the blur calculations.
It's like trying to take a clear picture through a messy window.
Exactly.
You just can't get everything in focus.
Right. But deep focus, because it's using AI, it was able to cut through all that clutter and accurately estimate the depth, even in those really tricky situations.
Wow.
It's like it has this intuitive sense of how depth works in the real world.
That's wild. It's like deep focus has X-ray vision for depth.
Yeah.
But even with all these successes, the paper does mention that there are still some challenges, right?
Of course. There's always room for improvement.
Like what kinds of things are they still working on?
Well, one thing that still trips up deep focus is semi-transparent objects,
Oh, okay.
like glass.
Glass, yeah.
With glass, Light passes through it in all sorts of weird ways, right?
Yeah.
So there isn't just one single depth value.
Right.
It's like trying to focus on a mirage or something.
Yeah, get it.
The depth information is really tricky because the light is playing tricks on us.
It's like trying to pin down a moving target.
Exactly.
So it sounds like figuring out how to handle glass and other translucent objects. That's still on the deep focus to-do list.
Yeah, definitely.
Are there any other limitations? Like, are there areas where deep focus might not perform as well?
Well, another area they're still working on is handling scenes with really extreme depth ranges.
Right.
You see, deep focus was trained on scenes with a certain range of depths.
Right.
And it might have some trouble when things get too close or too far away.
Like if you're trying to simulate, I don't know, a tiny ant crawling on your hand or a distant galaxy in space.
Exactly. It's like any skill you get better with practice. And deep focus needs more practice with those really extreme depths and areas.
But even with those limitations, what deep focus has already achieved is still pretty incredible.
Oh, for sure.
It's like a student who aced all their exams but still has a few things to learn.
That's a great way to put it.
Speaking of learning, let's shift gears a bit and talk about the bigger picture.
Yeah.
You know, we've talked about the potential of deep focus beyond gaming.
Right.
I'd love to kind of dive deeper into that.
Yeah, let's do it.
What other fields do you think could really benefit from this technology?
Well, we touched on medical training earlier.
Yeah.
Just imagine surgeons being able to practice these complex procedures in a VR environment.
Right.
That feels so real. It's like they're actually operating on a patient.
Yeah. It would be like having a flight simulator for surgeons.
Exactly.
They could hone their skills, build their confidence, and avoid any risks to real patients.
Absolutely.
That's incredible. And it's not just limited to surgery, right?
Nope.
Deep focus could also revolutionize medical education in general.
Oh, yeah.
Students could explore these really detailed virtual models of the human body. They could zoom in, zoom out, see everything from organs to individual cells.
It'd make learning so much more engaging.
It would be like taking a field trip inside the human body.
I love that analogy.
What other fields come to mind?
Well, architecture and design is another one with huge potential.
Oh, yeah, we talked about that a bit earlier.
Instead of just looking at blueprints, architects could create these virtual walkthroughs that let clients experience the space before it's even built.
So they could actually get a feel for what it would be like to be in that building.
Exactly. And they could experiment with different materials, colors, lighting.
All in real time.
Yeah. It would be like having a virtual interior designer at your fingertips.
That would be incredible. Streamline the design process, avoid costly mistakes.
For sure.
Make sure everyone's on the same page.
Absolutely.
And it's not just buildings, right?
No, not at all. Think about designing cars, airplanes, even entire cities in VR.
With this level of realism, the possibilities are pretty mind-boggling.
They really are.
You know, we've talked about how deep focus could revolutionize how we learn and work. But what about how we experience the world around us?
That's a great point.
Could this technology impact how we travel, how we connect with each other?
You're hitting on some really exciting possibilities.
I'm just thinking out loud here.
No, I love it.
Imagine being able to visit distant places in VR. Not just seeing them, but feeling like you're really there. Interacting with the environment, maybe even meeting people.
It would open up a whole new world of travel and cultural exchange.
Especially for people who might not be able to travel in real life.
Exactly. And think about the implications for education.
Oh, yeah.
Students could take virtual field trips to ancient ruins, explore the Amazon rainforest, even walk on the moon.
All from the comfort of their classroom.
It would be incredible.
Like having the entire world at your fingertips.
And not just seeing it, but truly experiencing it.
That makes me think about how deep focus could even change the way we connect with each other.
How so?
Well, imagine being able to have virtual meetings or hangouts with friends and family that feel as real as being in the same room.
That would be amazing. We could break down geographical barriers.
Bring people closer together.
It's a really powerful idea.
I'm getting so excited about the future.
Me too.
It's like deep focus is a doorway to this whole new world of possibilities.
It really is.
Not just in VR, but in how we learn, work, play, and connect with each other.
And remember, we're still just at the beginning of all of this.
Right.
As deep focus continues to evolve and improve, who knows what other amazing applications we'll find.
It's really incredible to think about.
It is.
You know, this whole conversation has really sparked my curiosity about the technical side of things.
Oh, yeah.
I'm wondering about those RGBD images you mentioned earlier.
Uh-huh.
What are those exactly?
So an RGBD image is basically like a regular color image, the
Okay.
kind you see on your phone.
Right.
But it has this extra layer of information. It's not just showing you the colors, it's also telling you how far away each object is.
So it's like a color photo that comes with a built-in depth map.
Exactly.
That's pretty cool. But how do computers actually generate that depth information?
There are a few different ways to do it.
Hmm.
One common method is to use two slightly offset cameras.
Oh, like our eyes.
Exactly. Just like our own eyes.
So it's like giving computers 3D vision.
Yeah, that's a good way to think about it.
And then Defocus takes that depth information
Uh-huh.
and uses it to create those realistic blur effects.
It's like giving VR a dose of human perception.
The paper also mentioned something called circle of confusion when they're talking about how deep focus simulates blur.
Oh, yeah.
I have to admit, that sounds a bit confusing.
It is a bit of a technical term.
Can you break it down for us?
Imagine you're looking at a scene
Okay.
with a sharp object in the foreground
Uh-huh.
and then a blurry background.
Right.
That blurry background is actually creating tiny circles of light on your retina.
Oh, interesting.
Those are the circles of confusion.
Okay.
And the size and shape of those circles. They depend on things like how far away the object is and how your eye is focused.
So it's not just like a random blur?
Yeah,
There's
right.
actual science behind it.
Absolutely. There's a lot of physics and math involved.
That's fascinating. So how does deep focus use these circles of confusion?
Well, Defocus has learned to calculate and apply those circles of confusion really accurately. It's basically simulating the entire process of how our eyes focus and perceive blur.
Wow. So it's not just enhancing VR, it's actually recreating the way we see the world.
That's a great way to put it.
But how does the AI actually learn to do all of this?
That's a great question. They train it using these massive data sets of images and depth maps.
So it's like showing a child thousands of examples of how things look at different distances.
Exactly, with different amounts of blur.
And through that training, deep focus learns the relationship between depth, focus, and blur.
It's like giving the AI a crash course in human vision.
That's incredible. And once it's learned those rules, it can apply them to any new scene, even if it's never seen it before.
Exactly. That's the beauty of deep learning.
You know, it sounds like a lot of work went into developing deep focus.
It definitely did.
Are there any areas where they're looking to improve or expand its capabilities in the future?
For sure. One area they're focusing on is making deep focus even more efficient.
Okay.
Remember we talked about those interleaving layers?
Yeah.
They're working on making those even better. So deep focus can run faster and smoother, even on devices that don't have a lot of processing power.
So it could work on things like mobile VR headsets.
Exactly.
What other areas of improvement are on the horizon?
Well, another exciting direction is integrating deep focus with other AI systems.
Oh, interesting.
Like imagine combining it with AIs that can generate realistic sounds
Okay.
or even simulate touch.
Whoa, so a VR experience where you can see things in incredible detail and depth, but also hear things and feel things realistically.
Exactly. It would be like blurring the lines between the virtual and the real even further.
It would be incredible.
And as AI keeps advancing, we can expect even more amazing breakthroughs like this.
It's mind-blowing to think about.
It really is.
Well, this has been a truly fascinating journey into the world of deep focus.
It has.
We've gone from understanding the science behind it to imagining its potential across so many different fields.
It's been a pleasure exploring this topic with you.
Likewise, you know, the future of AI and virtual reality is filled with possibilities.
Absolutely. It's such an exciting time to be witnessing these developments.
Absolutely. And to our listeners, we hope you've enjoyed this deep dive as much as we have.
We encourage you to check out the research paper yourself.
Keep exploring the ever-evolving world of technology.
Until next time.
Keep those minds curious and those imaginations sparked. So we've talked about these RGBD images and how they give computers a sense of depth. But how does deep focus actually use that information to create those realistic blur effects?
Yeah. Well, it all comes down to how our eyes work. You see, when we focus on something, our eyes create this area of sharpness, and everything else that's not in focus, it appears blurry.
Right.
And that blur isn't just random. It follows specific patterns based on how far away things are.
I see.
Deep focus has learned to mimic that process.
So it's not just adding blur, it's adding the right kind of blur.
Exactly. It's like it's learned the language of human vision.
That's incredible, but how does it actually do that?
Well, remember those RGBD images we talked about?
Yeah, the ones with the depth information.
Deep focus takes those images and uses them to figure out how much blur to apply to different parts of the scene.
So it's like it's looking at the depth map and saying, okay, this object is closer, so it should be sharper, and that object is further away, so it should be blurrier.
Yeah, that's a good way to think about it.
It's like it's giving VR a dose of human perception.
Exactly. It's bridging the gap between how computers see the world and how we see it.
That's really cool. You know, all this talk about blur and focus is making me realize how complex our vision really is.
It really is. We take it for granted, but our brains are doing all these incredible calculations every second.
It's like a supercomputer in our heads.
And deep focus is tapping into that in a way.
It's mimicking those calculations.
Exactly. And by doing that, it's creating VR experiences that feel more natural, more immersive.
More real.
Yeah.
This has been an amazing deep dive into deep focus.
It has.
We've learned so much about the technology, the science behind it, and its potential applications.
It's really cutting edge stuff.
It is. And it's really got me thinking about the future of VR and AI.
Me too.
Who knows what other incredible breakthroughs are just around the corner.
It's an exciting time to be alive, that's for sure.
Well, on that note, I think we've reached the end of our deep dive.
It's been a pleasure exploring this with you.
Likewise. To our listeners, we hope you've enjoyed this journey into the world of deep focus.
We encourage you to keep exploring, keep learning, and keep those imaginations fired up.
Until next time.